Welcome back to Science Modernizers and welcome back to this video. Welcome back to our channel. Today we are going to have a lesson on the theory of quadratic equation. So let's get the lesson objectives. So the first is, at the end of this lesson, the learner should be able to 1. Define a quadratic expression and equation. 2. Know the respective methods involved in solving a quadratic equation. 3. We have the method of factorization, and lastly, when the coefficient, that is, we are going to see the particular case when the coefficient of x squared, that is a, is equal to 1. So let's get started with the video. What actually is a quadratic equation, and what actually is a quadratic expression? So we are going to begin with the definition of a quadratic expression. So on definition, a quadratic expressions or quadratic expressions are polynomial expressions of degree 2 in one variable, that is of type f of x is equal to ax squared plus bx plus c, where a, b and c are real numbers and a is different from 0. So examples of expressions are simply that 3x squared plus x plus 5, negative x squared plus 7x plus 5, x squared plus x. So we realize that these expressions are not equated to any other thing on the right hand side, and so we call them quadratic expressions. And this particular expression, f of x equal to ax squared plus bx plus c, represents what we call a parabola on the Cartesian plane. A parabola on the Cartesian plane. So let's then define what is a quadratic equation. So a quadratic polynomial, when equated to 0, becomes a quadratic equation. So when the expression f of x is equal to ax squared plus bx plus c is equated to 0, we get a quadratic equation. So in other terms, a quadratic equation is a second degree algebraic equation. The values of x satisfying the equations are called the roots of the quadratic equation. So the general form of the quadratic equation is ax squared plus bx plus c equal to 0. And also the same conditions hold like those of an expression on a, b and c, where a, b and c are all real numbers such that a should be different from 0. So examples are, we see, consider back these same expressions and now equate them to 0. So equating them to 0 makes them to become a quadratic equation, and so on and so forth. And on the Cartesian plane, they all represent parabolas with respective solutions c, alpha and beta. So how then can we solve quadratic equations, and what are the principal methods involved in solving a quadratic equation? So there are 4 principal methods involved, in which 3 are most commonly used. So these methods involve, the first one is the method of factorization, and under the method of factorization 2 cases arise. So what are the 2 cases? We have the first, when the coefficient of x squared is equal to 1, that is a is equal to 1, and the next is when the coefficient of x squared, a, is different from 0 and 1. So these are the respective cases involved in the method of factorization. The others involve the method of completing the squares and the method of using the quadratic formula. And the quadratic formula is simply a derivation which when completing the square of the equation ax squared plus bx plus c equals to 0, completing the squares of this equation and making x the subject of the formula leads to the quadratic formula. And the quadratic formula was discovered by the Arab mathematician Mohammed bin Musa. So this is the author of the quadratic formula. And so the foot method, which is used in rare occasions, is what we call the graphical method. So analyzing a quadratic equation using the graphical method. So the graphical method entails in sketching the respective parabola on the Cartesian plane, and the points where the parabola cuts the respective coordinate axes, let's say at x1 and x2, are simply the solutions of the quadratic equation. So the parabola, the shape of the parabola is dependent so much on the sign of a. If a is positive, then we have a parabola of this nature. And if a is negative, we have a parabola which has a maximum value. Okay. So we are going to begin with the first method, the very first method, which is the method of factorization. And we are going to begin with the first case when a is equal to 1. So let's see the algorithm in solving this particular. So the first thing is we are given the quadratic equation ax squared plus bx plus c equal to 0. And here we have to notice that a is equal to 1. And so our quadratic equation will be written now in the form x squared plus bx plus c equal to 0. So what is the first step involved? So we begin by looking for two numbers, let's say alpha and beta, such that the product of the sum of those two numbers should give us b, and the product of the two numbers should give us c. And the easiest way for us to get all these values is for us to write down the factors of c. The factors of c. So both the positive and negative factors will enable us to easily get the two values alpha and beta. And so when factorizing, the factorized form of the quadratic equation will simply be of the form x plus alpha into x plus beta. So this can actually be derived by replacing the value of x plus alpha into the equation ax squared plus bx plus c equal to 0. So if we replace that, we are going to get x squared, b is alpha plus beta, all of that times x, plus c, which is alpha beta. And so expanding, we have x squared plus alpha x plus beta x plus alpha beta equal to 0. So at this level, we see that we can factor out x. So x is common, we have x into x plus alpha, plus here beta is common, we have beta into x plus alpha equal to 0. And so we clearly see that this we can further factorize this, that x plus alpha is common, so we can write it as x plus alpha into x plus beta equal to 0. So this can actually be factorized in this form. So definitely this is how we solve by the method of factorization. So clearly we see that since the product of these two expressions is equal to 0, it means either x plus alpha is equal to 0 or x plus beta is equal to 0. And so resolving those respective linear equations leads to a case where we have x is equal to negative alpha and x is equal to negative beta. So this is what we get. So let's get a practical example on the board. Okay, so we are going to take a practical example on the board. So let's take the case we have the equation x squared plus 5x plus 6 is equal to 0, and we want to solve this using the method of factorization. So the first thing, as stated, we said we have to look for the factors of c, and here we observe that c is equal to 6. So what then will be the factors of c? So the factors of 6 will simply be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 itself. So we are now looking for two numbers such that the sum of those two numbers should give us 5, and the product of those two numbers should give us 6. And clearly amongst the factors we see that the two numbers are 2 and 3. So we verify that 2 plus 3 gives 5 and 2 times 3 gives 6. And so the next thing we do is we simply replace our 5 with those two values, that's 2 and 3. So in other words, we have this as x squared plus, now we are going to get 5x. We are going to replace 5x simply by 2x plus 3x, and all of this plus 6 is equal to 0. And so factorizing, we get that here we have x that is common on both sides, so I have x into x plus 2, plus here we have 3 that is common, since 6 is a multiple of 3, so we are going to have 3 into x plus 2 equal to 0. And so this expression x plus 2 is common, so we can factor it out. So this means we have x plus 2 into what will be left, it's x plus 3 equal to 0. And so in order for us to get the possible roots, either x plus 2 is equal to 0 or x plus 3 is equal to 0. So this means either x is equal to negative 2 or x is equal to negative 3. So these are the respective solutions of this quadratic equation, and so it can also be gotten graphically. So let's go to, so what then is a summary of the lesson? So we have seen the definition of a quadratic equation and a quadratic expression. So a quadratic equation is different from a quadratic expression. So expressions can simply be written of the form, let's say x squared plus 2x plus 1. And equations are of the form x squared plus 2x plus 1 equal to 0. Now, in the next is, these are the respective examples. And also, we saw the method of factorization. Now, I'm going to lay emphasis on the fact that we saw that we are looking for two numbers alpha and beta c, such that alpha plus beta should give us b and alpha beta should give us c. Now, in the equation, ax squared plus bx plus c equal to 0. So we saw that the case is when a is equal to 1. Now I'm going to lay emphasis on the fact that if the number is such that alpha is equal to beta, so we are talking of the expression which we are going to have is called a perfect square. A perfect square. An example is quoted on the screen. X squared plus 2x plus 1. So here we are simply supposed to look for the factors of c, and we observe that c is 1. The factors of 1 is simply plus or minus 1. So we keep those factors. So we are looking out for two numbers that when we multiply we have 1 and when we add we have 2. So those numbers are simply 1 and 1. And we see that factorizing the expression x squared plus 2x plus 1 will simply be written in the form x plus 1 into x plus 1. So this also is the same as x plus 1, all of that squared. So this is what we call a perfect square. So if alpha is equal to beta, we are dealing with a perfect square. So that is a brief summary of what we have seen in today's lesson. So this brings us to the end of this video. Thanks for watching, and please do not forget to like, share, subscribe, and also for any question you can leave your questions in the comment section and reach out very soon. So see us in the next video.